Hello, fourth graders. Welcome to robotics class. This is week 20. Do you guys like my new background? I am in a technology/robotics lab. I don't know where it is, but it looks pretty cool. And could you imagine if this is what our technology room looked like? Anyways, I thought it would be fun to just pretend. Why not, right? I think we've learned that we can pretend with virtual worlds, right? So I hope you guys are doing okay this week. We actually are going to continue with our lessons that we've been going through, learning about the engineering design process. So last week we went through all of the steps in the process. So it was kind of like an overview, right? Just to get you guys to see that when an engineer thinks about, well, how am I going to design, whatever it is that they want to design, there's a whole process, right? And it's pretty fascinating to learn about it. And this week, we're going to dig a little bit deeper into defining the problem and finding a solution. So these are two of the steps in our engineering process, right? And I really like the videos that we've been watching with the girl there, and she really does a good job, I think, of making it relatable for kids your age. So we're gonna watch the rest of the video. Well, actually, there's a few more parts to it. So we're gonna watch the part today about defining the problem and finding a solution, and then next week we'll continue, and she goes a little bit deeper into a little bit more of the topics that have to do with this. So what I would suggest is if you have a notebook, a binder, a piece of paper, that wherever you like have your robotic stuff, take out a paper and something to write with, because you should definitely jot down some notes while we're going through, because your homework is like a review sheet, which pretty much is going over everything that they talk about in the video. So it would just be a lot easier for you to do your homework if you jot down some notes, okay? And what was I going to say? Of course, you could always go back to the video if you need to. I mean, that's totally fine too. And I mean, that's why I've been doing videos, because I feel like with technology and robotics, it's just something that, you sometimes you do need to go back, especially when we're doing coding. And things like that. You don't just get it the first time, right? You need to go back. You probably have questions. So I feel like a video is definitely helpful to be able to pause or go back to something. So let me put on the lesson, and then after we'll come back and we will talk about it. Okay, so hang on one second. Okay, here we go.
Problems. We've all got them. You, me, T-Swift, Tony Stark. Some problems, like forgetting to do your homework, might seem like a pretty big deal to you, but when you compare them to other bigger problems, they're really not so bad. Like what kind of bigger problems? Well, the kinds of problems engineers face, like how to safely fly hundreds of people through the air in a small vehicle from one country to another, or how to make an eco-friendly building in a seaside town that can withstand hurricane-force winds, or how to send a bunch of earthbound humans hurtling off into space and, get them back. That homework doesn't seem like such a big problem anymore, does it? Okay, to be clear, I'm not saying that you don't have to do your homework. If you didn't, it would definitely be a problem. Just not as big as, like, having to invent a spaceship. And that's the kind of stuff that engineers do. Engineers are people who want to know how and why things work. Not only that, they actually design and build things like machines, systems, or structures to help solve specific problems. All engineers, whatever type they are, follow the same series of steps when trying to solve a problem. You'll remember these steps as the engineering process. And the first step in that process is defining the problem. When an engineer identifies a problem he or she hopes to solve. But that first step isn't as simple as you think it is. So it's time for our big question. How does an engineer define a problem? Let's come up with a fake problem to solve, and we'll see what we wind up with. Pretend you're on one side of a very big canyon, and you need to get to the other side. So that's the problem you need to solve, right? How to cross this very big canyon. Sort of, but not exactly. We can do better. If I was an engineer and found myself on one side of that huge canyon, here's how I'd go about identifying the problem. I'd ask questions, a lot of questions, all the questions. I need to cross this very big canyon. But is that my actual problem? This canyon is very big and I need to get to the other side. I know, I'll cross a bridge. Wait, is there a bridge? Yeah, there's no bridge. Okay, can I climb down one side of the canyon and then up the other side? Definitely not. Way too deep. Plus, there's a roaring river at the bottom I'd have to figure out how to cross. So I can't cross the canyon by bridge, I can't climb down and up, and I can't swim across it. What's something I can do that doesn't require a bridge, climbing, or swimming? I know, I need to find a way to fly across the canyon. And that's my problem. More importantly, that's my solvable problem. How do I fly across this very big canyon? It took a little bit of thinking and a whole lot of questions, but how can you fly across the canyon is an easier problem to address than the much less specific, I'm on one side of a big canyon and I want to get to the other side, and I don't know how to get across it. Which, strictly speaking, isn't a question, it's just complaining about a problem really loudly. So defining the problem in a solvable way is really key to being a good engineer. While that first step might seem pretty easy, make sure you treat it like the super important step that it is, because it sets the stage for all of the steps of the engineering process that follow. If you don't define a potentially solvable problem from the start, you might never, well, solve it. So an engineer asks a lot of questions to define a problem as specifically as they can, and most importantly, as something that can be solved. So how is engineer Sabrina going to find a way to fly across that gorge? You're gonna have to solve that problem by watching our next lesson. Problems, problems, problems. We've been learning a lot about engineering lately, and engineering always starts with a problem that needs to be solved. But I'm tired of talking about problems, so let's talk about solutions instead. We've already learned about how engineers define problems. Now it's time to discover how they define success. I don't mean how they define success, like in general, like success is graduating from a good school, or success is getting a good bonus check at work, or success is winning a lifetime supply of macaroni and cheese. Although, I'm not gonna lie, that sounds like success to me. When engineers define success, they do it in relation to the problem they're trying to solve. So, for example, what does a successful solution to my problem look like? The big question we're asking today is what makes a solution successful? Okay, let's back up a bit. A solution is what again? A solution is something that an engineer designs or builds to solve a problem he or she has. Some solutions that engineers have come up with include the telephone, a solution to the problem of how people in different places can communicate with each other. Or the refrigerator, a solution to not being able to keep food fresh for long periods of time. Or light bulbs, a solution to not being able to see at night using something that's safer, brighter, and more reliable than an open flame. Every day, engineers design and build solutions, but how do they decide which of the many potential solutions that they brainstorm will be the most successful? I think an example would be helpful here. And we've already invented a fake problem, so why not invent a fake solution too? Back to the canyon. You know that insanely deep one with no bridge and the raging river at the bottom of it? Yeah, that one. The problem we defined at that spot was how do we fly across this canyon? I'll be your stand-in engineer again. Being a good engineer, I know it's time to identify the criteria for my solution. Basically, I need to figure out what things my solution needs to do in order to be considered successful. Think of it like making a checklist. Number 1, it should get me to the other side. And let me be more specific, it should get me to the other side alive. Number 2, the thing that gets me to the other side, should be something I currently have or can easily access. Number 3, it would be nice if I could reuse whatever it is once I'm on the other side. Now, if Superman's Fortress of Solitude was nearby, I'd snag him and make him fly me over this canyon, no prob. But sadly, I don't have access to Superman's secret lair. So, like any other engineer, I have to make do with what I have. So, what do I have? I've got the tent that I camped with, and that's about it. You guys, I can make a hang glider out of my tent. It's a resource I already have, and if I build it properly, it will get me to the other side alive, which is ultimately where I want to be. Plus, bonus, I can dismantle the glider on the other side and use the pieces for their original purpose, keeping me sheltered from lions and tigers and bears. Oh my! So, Superman's a solution in that if he were real, and if I could somehow contact him to get him to carry me over this canyon, he could get me to the other side alive. But he's not the most successful solution, because he doesn't meet all of my criteria. He's not currently with me, and I can't easily find him. I mean, the whole point of a secret lair is that it's secret. So, a hang glider meets all of my criteria, which means that's our solution. We'll fly across this very big canyon with a hang glider. And of all the solutions that an engineer can brainstorm to whatever problem he or she has, the most successful one, the one that meets all of or most of the criteria, is the one that engineers actually attempt to design. Now, actually making a hang glider out of a tent is a different step in the engineering process, so it's one that we kind of fortunately don't have to mess with today, because I have zero idea about how to build or fly a hang glider. And anyway, remember that this is a totally fake made-up solution. Don't go jumping into a canyon or anything with a tent, okay? We're here to solve problems, not create new ones. We've talked about problems. And hey, we've all got them. But there are
Okay, so hopefully you enjoyed that and it was helping you to understand a little bit more details about how engineers define problems and solve problems. So let's go over the questions. So what were the 3 examples of problems engineers face that were shared at the beginning of the video? So remember, she was like going through a few things. The first one was talking about airplanes, right? How can we safely fly people across to different places? And then the next one was designing a building in a seaside town that can withstand hurricane force winds. So obviously engineers would have to think, how in the world are they going to make sure that the building doesn't fly away, right? And the third one was sending people into space, right, and getting them back safely. And of course, there's zillions of problems that engineers solve every single day. These were just 3 that she shared in the video. So the next question says, engineers are people who want to know blank and blank things work. They want to know how and why things work, right? What is the first step in the engineering design process? We know that it's to define the problem, right? Which is what we've been learning about. And hopefully, some of you guys may be called to be engineers when you get older, and you could already sense it now. You're just one of those people who's always, you have a good eye. You see when there's a problem, you're able to define it, and you're pretty good at coming up with solutions. So that could be that could be a gift that God is placing in you for you to pursue in your future. Okay, the next question says, how does an engineer define a problem? And this is probably the most fun part, asking a lot of questions, right? Until they're able to figure out a solvable problem, something that they actually feel like they can solve. And again, some of you guys, that might be you right now. You're like the one who wants to know everything. Why did this happen? How does this work? What are we going to do about this? Why didn't this work? Why can't I do this? How am I going to figure this out, right? How does that happen? And you're just always asking questions, 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 questions. And so maybe it's just a passion and a desire that God has placed in you to really just work and design, solutions to problems. Okay, so let's keep reviewing. Engineering always starts with a blank that needs to be solved. Easy, it starts with a problem, right? A solution is something an engineer blank or builds to solve a problem he or she has. What do you guys think? So it's something that an engineer designs or builds, right? And what makes a solution successful? Well, it should meet all or most of the criteria, right? And so remember, they had the little checklist. So that's going to be your homework, to just complete the review sheet. And then next week, we're going to learn a little bit more about something called a variable. And so this will be something to help you guys too, because we are going to be moving into coding in our technology part. So remember, you guys have you see me twice a week, right? And that's new, because in 4th grade, they offer technology, and it's separate from robotics, but believe it or not, they go together because you need both of them. And with robotics, we've been mainly just focusing on robotics, robots, engineering, and all of that. And as you guys move along in the years, we'll be doing some coding, where we code virtual robots, which is what the 5th graders are doing right now. But in technology class, we use code.org, and we're going to be starting to use that. And so some of the terms like variable, these are things that you're going to be hearing because they're part of code, and code is part of robotics. So it's all linked together. So it's good because you're learning a lot of things, and they all go together and they all work together. And so that'll be what we'll be focusing on next week. So for this week, just type up the answers to this review sheet, send it in. I think it's an easy 100 because you guys all took notes. We went over it. And hopefully you're starting to expand your knowledge a little bit more about engineering in the process. And maybe you're even starting to think about things a little bit differently. You're opening up your mind, and you're just becoming a problem solver, solution maker, and you're growing your brain, right? And you're enjoying challenges, right? Because remember, people who work with robots and code, they love challenges, and they love to be able to do things that are hard. and to show people that how to get things done, right? They're not running away when something's hard. They really enjoy it. Okay, guys, so have a good week and I'll see you guys next time. All right. Bye, guys.